All right, today we are continuing our discussion on the properties of matter. This is section 2.1. There are a number of objectives for this section, and that includes being able to classify pure substances into elements and compounds, describing characteristics of elements and their symbols, describing characteristics of a compound, distinguishing between substances and mixtures, and classifying mixtures as well into several categories. In addition to this, we're also going to be talking about the periodic table. Some terms we need to discuss include materials, and that means it consists of solids, liquids, and gases as we discuss them in science. Pure substances, which have the same composition throughout. In cooking, some examples include salt and sugar, but you notice that every bit of sugar that you use in a recipe or salt tastes the same, whether you get it out of a shaker, if you have it in a container, or if you use it in little packets. Additionally, we'll be looking at elements, which cannot be broken down into simpler substances. They have fixed compositions because they contain one type of atom each. When we're looking at the periodic table, and yours is on the next slide if you want to review that. If you don't have your paper copy with you, that's fine. It includes the key that's also listed on this slide. And we have to know the information that's included in it. All four elements or parts of each description is important. The first is the atomic number at the very top. Sometimes you'll notice that's off to the left-hand side. The elemental symbol, and usually it's only a single letter which is capitalized. Sometimes there's a second letter, and that is always lowercase. Then you have the element name. In this case, we're looking at hydrogen, and the average atomic mass. You need to know the difference between the atomic mass and atomic number because that will be included on your test coming up. An element has a fixed composition because it only contains one type of atom. No two elements contain the same type of atom. And it's important for you to know that some elements are solid at room temperature. Others are gases at room temperature, and some are liquids at room temperature. The two that are included as liquids in room temperature would be bromine and mercury, and both are poisonous. Most of you did very well on this section for the homework last week. Do take some time to look over it and be familiar with how to use the periodic table if you have a copy. As I mentioned, I don't have students memorize these. Your standards from the state don't require it. They're just asking you to be able to use this periodic table on a test and that you're able to find all four parts of each element. This image is just showing us what the difference in pure substances would be. For an element, those atoms are all the same, so you'll notice they're all green circles that are included in the composition. And for a compound, there are two. One is purple, one is green, and it's distributed evenly throughout the substance. A compound always contains two or more elements joined in a fixed proportion. A compound is a substance that is made from two or more simple substances that can be broken down into those simpler substances. The simpler substances are either elements or they're compounds, and in this case we're looking at water as the compound, H2O, and that's because most of us are familiar with that chemical formula. You'll notice that hydrogen at the top from our periodic table and oxygen are both included in this compound. Technically, it's two hydrogens for every one oxygen. And the illustration at the bottom in gray and red on the white background is the chemical formula. So this is something we'll be looking at very soon. Next, we're looking at mixtures. Properties of a mixture can vary greatly because the composition is not fixed. They tend to be less constant than those of a substance. An example would be salsa as a heterogeneous mixture, and that's because you can see the individual pieces of jalapeno and tomato and onion in there, pieces of cilantro as well. And in that case, you're looking at being able to see those individual elements, that it doesn't mash together in one cohesive group. But that also means that when you take a bite, you might have more cilantro or less jalapeno than you'd prefer, because we're looking at that ratio first and foremost of how much jalapeno is in the salsa mix, how much was spooned into the container, how much did you put on your chip, and the general distribution. There might be more cilantro at the bottom of the salsa container, and there might be more jalapeno at the top if it wasn't well mixed. All right, if we think back to our salsa example for heterogeneous, we're going to look at now at homogeneous mixtures, which would include something like a can of tomato sauce. It's just pureed tomatoes in there versus a chunky salsa that has lots of different stuff in there, and you can see the individual pieces, if that makes sense. In a homogeneous mixture, substances are evenly distributed to the point that it can be difficult to distinguish one substance from another. An example from your textbook is that you can take multiple water samples from a pool at various depths. Whether you go to the low end of the pool or you go to the deep end where the diving board is, that's still a water that is mixed pretty well and is very similar across the board. Now you might get two different readings, but not like you would in your salsa example. If you place a spoonful of sugar in a glass of hot water and stir, the sugar dissolves in the water. You've seen this in class with my hot tea. If I had a clear glass for you to look through at the tea at the beginning of class, it wouldn't look any different at the end of class, unless, of course, I drank it. The result is a homogeneous mixture of sugar and water. When substances dissolve and form a homogeneous mixture, the mixture that forms is a solution. Liquid solutions are easy to recognize. They do not separate into distinct layers over time. If you pour a liquid solution through a filter, none of those substances in the solution can be trapped in the filter. The particles are very small. Also, light will pass through it without being scattered, and that's also due to the size of the small particles that are included in a solution. When you're talking about suspensions, however, if you've ever seen the instructions to shake well before using on a bottle, you have actually used a suspension before. And that is a heterogeneous mixture that separates into layers over time. You could also use a filter to separate the elements of a suspension. And the suspended particles can settle out of the mixture. They can not only be trapped in a filter, they will also remain in layers over time and can be cloudy to look through because of the size of the particles. Next, you have colloids. Milk is a mixture of substances that includes water, sugar, protein, and fat. When you're taking fresh cow's milk on the farm and you put it in a container, you allow it to stand, the cream will actually rise to the top, and a big portion of that cream would be fat. In milk that you purchase from the store, it's gone through a process. It's now homogenized. That fat layer is worked into the entire milk. And in that process, it's so evenly dispersed that it cannot separate out. It won't become layers. Some of us are still in the habit of shaking our milk. That's where that comes from, especially if you have older family members. Because if you were on the farm, you would have to shake the fat at the top to disperse it through the rest of the milk. A colloid contains some particles that are intermediate in size between small particles of a solution and large particles in a suspension. Like solutions, colloids do not separate into layers. You cannot use a filter to separate the parts of the colloid. The scattering of light property can also be used to distinguish colloids and suspensions from solutions, and that's because light is somewhat scattered, but not to the point of suspension. All right, for your assessment, I'm going to have you write that out, and these questions are included in your 2.1 review. We have 1 through 7. Number 7 is actually number 8 in your textbook, and we're skipping number 7 in the text, just so you're aware. And I will read them for you. And I'm asking you to write out just your response. You don't have to write the full question, although that can be very helpful for you when you go to take your mastery check. So I'll leave it optional. Number 1, why does every sample of a given substance have the same properties? Number 2, explain why the composition of an element is fixed. Number 3, describe the composition of a compound. Number 4, why can the properties of a mixture vary? Number 5, on what basis can mixtures be classified as solutions, suspensions, or colloids? Number 6, if you added salt instead of sugar to a pitcher of lemonade, how would this change the properties of the lemonade? And number 7, fresh milk is a suspension. After it is homogenized, it becomes a colloid. What happens to the sizes of the drops of fat in the milk in the homogenation process, based on your understanding of section 2.1?